Okay, can you all hear me all right?
Yeah.
Brilliant, okay. Well, thank you all for coming this evening, and it's good to see so many here today. And thank you also too for the IET guys who've organised it all, because I know a lot of hard work goes into doing an event like this. And I expect some of you may have ailing turntables or Tonearms, and that's a great opportunity really to let you know about our products as well. Well, Origin Live, if I can just talk a little bit about introducing myself. I'm Mark Baker, founded Origin Live about just over 30 years ago in 1986. And we weren't building turntables back then, but we started off in cables actually. So the company now is a small engineering factory basically occupying 7,000 square foot and running CNC machines. We employ 12 people, that's including part-timers. We do all of our work in-house, so we've invested a lot of money. This is a £129,000 CNC, which gave me serious heart attacks when it came to investing in it. This is an older machine, the first one we had, which is an old Japanese CNC machine, and this is our milling machine. Our listening room where we do development and also demonstrate to anyone who wants to come and hear our stuff basically. This is some development turntable models we've got on the go. So to kind of introduce the subject of record players, they vary from the cheapo £69 models that you find in John Lewis and Sainsbury's, and please don't go and buy one of those things because the diamond tips are not even cut, they'll just shred your precious grooves inside 2 or 3 plays. So serious record players start at about £160, and we've got one here with us tonight, which you're welcome to listen to. The proliferation in turntables is absolutely phenomenal now. I went round to the high-end show in Munich, which is the biggest high-end show in the world, which is held every year, and I counted 400 different models of turntable. So you can imagine the competition we're up against. So I'm just going to run through a few of those. These are sort of my happy snaps as I was wandering around the show. Now, hi-fi has been called the equivalent of men's jewellery, and there is an element of truth in that, but it's not. I mean, I don't subscribe to this entirely because, unlike men's jewellery, you do get a performance increase when you buy an expensive turntable, whereas if I buy a £40,000 Rolex, I don't even have a light on it, you know, when I wake up in the middle of the night. So there's no functional difference there. But with record players, you do get better sound quality. This is a joke turntable, by the way. I think this is an interesting one. It came out a couple of years ago, and it floats on a pure magnetic field. Great gimmick. I had to listen, and I wasn't overly impressed. There's reasons for that. So this one is about 100,000 set you back. Transrotor, another transrotor. Okay, so a little bit of history on turntables. When I first started in hi-fi back in the 80s, it was undergoing quite a transition, because up to that point, everyone read about a product and they looked at the specifications and the build quality, and no one really talked very much about the sound quality. And it was only when Lynn arrived on the scene and started saying, and also everyone thought all turntables sounded the same. It was only when Lynn came on the scene and started saying, actually, turntables sound incredibly different, and unless you've got a good turntable, you're not going to get a very good sound out of your system. And his philosophy was rubbish in, rubbish out. If you don't get a good signal in, you're not going to get a good signal out, which makes perfect sense, really. I mean, I went around a very high-end show going back 30 years, and there was a £40,000 Goldman turntable playing through a £100 pair of Wharfdale Diamond speakers. And I heard quite a number of people saying they thought it was the best sound of the show. I know that might astonish people, but it's a kind of example of, rubbish in, rubbish out. So he then went round and started doing A/B comparisons, subjective musical comparisons of turntables, and the difference was jaw-dropping. People, found the LP12 phenomenally good in comparison to the competition. Well, I was deeply sceptical about this. So I read the magazine reviews, and I had a fairly inexpensive turntable, I think about £100 or something, and I had great difficulty thinking, well, why should a turntable make so much difference? And it was only when I was in a Lynn Dealers one day, just eavesdropping on a demonstration, that I was astonished, shocked at the difference between turntables, and from that point on I saved up for a second-hand Lynn, which was about 10 times the price of my humble deck. So what we're going to look at now is, why should a turntable make so much difference? And the first thing is the scale of signal magnification is unbelievable. We're talking about your average CD player or streamer is going to be kicking out 1 volt, and it gets to about 8 volts by the time it gets out of your speakers. When you're looking at a turntable, you're looking at between 0.05 millivolts and 5 volts. Sorry, 5 millivolts. So let's just take a nominal output of 1 millivolt, okay, as an average. That's got to be amplified 8,000 times by the time it gets to your speakers, which is absolutely colossal. So to try and illustrate this, I've got a slide of Mount Everest here, which is, what you can see in the picture is 12,000 feet, which is a very long way to climb, by the way. I haven't done it myself. So this is the top 1,200 feet, and we're just going to magnify in, and I've left a little Sainsbury's shopping bag at the top of Mount Everest here, which you can see that little red dot right on the very summit. Okay, so that gives a kind of idea of the huge scale. If you imagine that now as a tiny model at Mount Everest, we're going to magnify it up again through the range. Just takes a bit of time, but bear with it, please, because it just helps to kind of picture the scale. Okay, the next thing to help understand about record players is the Stylus movement. Now, everybody naturally thinks the Stylus are doing all the work, because that's the little needle that kind of moves through the grooves and generates this 1 millivolt signal that's then amplified up 8,000 times. And the movement of the Stylus is it goes from side to side through the grooves, and also goes up and down, so you're doing this sort of movement. And the closest representation, I hope this works, it's a clip I got from an Olympic skier for our team. It's a freestyle skier, and he's going through the mogul fields. I don't know how many of you have watched these freestyle skiers going down mogul fields, but they're doing about 1 turn every second as they go through the kind of humps in the snowfield. And you imagine that happening 30,000 times a second, and that's what the top-end stars are doing. It's, again, really crazy. And so the pressures on that Stylus and the forces acting on it and the forces it's kicking out are pretty high. So if you've got an ice skater, they're generally exerting about, I think it's 0.025 tons per square inch on the skates. The downhill skier, when he's kind of carving the edges going down the slalom, he's putting on about 0.06 tons per square inch. The Stylus, when it's going through the grooves, 8 tons per square inch. It momentarily melts the vinyl as it goes past, because the friction levels are so high. But some of you might be getting worried that you're going to be smelling melting vinyl or something. But no, it doesn't happen. It's like an ice skating ring, it's just so momentary. It only happens a tiny bit, And you've got about 2,000 plays of your record before it starts to kind of get serious wear. So on the stylus, you've got six degrees of movement, and these forces are generated because if you imagine the needle, it's going to be doing this, rocking side by side, side to side. It's also going to be experiencing backwards and forwards motion because the motor and the belt are actually kind of tugging all the time and putting in momentary little movements. So I won't go through them all because there's just not time, but it goes through those kind of things. The next thing to consider, so just to summarise, we've learned that there's massive scale involved with the amplification of your stylus. The tiniest movement is going to upset the movement of the stylus. And again, if you can imagine the downhill skier going down this mogul field, if the whole mogul field was undergoing a terrific earthquake at the time, you would be finding it more difficult to negotiate the grooves, and that's what happens to the stylus again when it's getting vibration. And the vibration that enters into a record player comes from, well, we're going to talk about 4 sources. The first is the motor, which is probably the biggest one. The second is the platter bearing, because the platter bearing, however well it's engineered, will generate a certain amount of friction. The third is the stylus itself, which is kicking out a lot of impulses into the record surface and also back through the tone arm. And then you've also got the ground-borne vibration, which, if you've really got your speakers turned up high, you'll feel that the mantelpiece is trembling a bit, and so that's what's going on there. But it's also more subtle than that because you've got ground-borne traffic, underground pumps. There's all sorts of things that give very low-level vibration into the record player. So what damage does all this vibration do? Well, the first is you've got the echo of notes which lead to smearing. So say you've got a tone, your tone arm's the biggest one. You've got a long tube and the stylus is at the end of it all. The stylus is going to start kicking out vibration, which is going to send the tone, which goes straight down the tone arm as a vibration, just like when you hit a railing, the vibration travels along and you can hear the thing go ding. Well, that vibration goes down, hits something, whether it's the bearing or whatever, and then goes straight up back into your cartridge. That's a delayed vibration which smears your sound quality. You've got the effect of waves combining. For instance, say we're now considering the platter, you've got motor vibration coming in through the belt or the direct drive or wherever it does. And then you've also got the bearing vibration. So those two will interact and cause another mess. We've got resonance, which tends to, going back to the tone arm, it's the easiest one to think of, everything has a resonant frequency. So besides the reflected vibration, the thing will also start going into resonance, and that will be a very narrow frequency band which will accentuate certain things. Like some tone arms have a very there's a kind of high frequency zing at certain notes. You can hear them, kicks them off. And damping, to try and get rid of that, people put down on damping, but damping has its own set of problems because there's no damping which actually evenly damps the frequency band. They all kind of operate in a certain narrow band and they hollow out the sound in that frequency. This is just communicating some of the issues and difficulties involved in producing this sort of a device which will amplify these tiny signals. You might think after hearing all that, well, just go digital. I mean, this is really too much of a struggle. But Michael Fremer is probably the most respected analog guy on the planet. Was interested in it. He came up to me at a show and said, Mark, it's interesting, but a lot of the guys who design DACs in Silicon Valley are starting to design turntables because they're fed up with all the difficulties that they're experiencing. And I'm thinking to myself, they probably don't know what they're in for yet. Just a very quick note about the hierarchy of vibration. We've got a little demo which we'd like to do after the meeting, where we put a £6,000 cartridge on one turntable and one at £600, which is a tenth of the price, on the other turntable. And what I think, I mean, I know what I think, but you'll be the judge. The £600 cartridge will outperform a £6,000 cartridge, and it's a really good cartridge, by the way. It's an award-winning cartridge, which some of the reviewers use as their reference. But it's a really interesting little comparison, that, to say, actually, it's not the cartridge which does all the business, it's what supports it. It's a bit like an electron microscope. Can't read anything unless you put it on an airbed, granite, on and on. So it's the same kind of principles. Okay, so principles of record player. Perfect speed stability is the first one. Most people think that's just about the thing going around an even speed. It's not. It's much more important than that. Much more important than that is how the deck responds to that tiny bang it gets through every groove that the stylus hits around its track. And there's micro milliseconds or whatever it is goes on at that time, and it's got to be able to cope instantaneously with that. So people use very high mass platters, or they use high torque motors. We'll get a bit more into that later. You've got a minimal vibration from the motor and the bearing. You want very low amplitudes of vibration. It amuses me at times because the reviews kind of go bang on about, oh, the resonant frequency was too high, the resonant frequency was too low, and all this kind of thing in the vibration. I'd much rather have a low amplitude of vibration. In other words, if the thing's vibrating at the wrong frequency and the movement is only this, it's going to be a lot better than something which is vibrating at the right frequency, but the movement is doing that, because obviously that's going to upset the stars far more. Okay, so this is a typical example of a high mass platter. Here we've got a 2-motor pulley system. You can see the 2 motors on either side of the platter there. Oops. And here we've got 3 belts to try and increase the torque, because obviously the pulley tends to slip a little bit as it's going round. Getting rid of sources of vibration. This is a clever idea. You've got 2 motors here, either side, and an idle wheel in the middle. So the 2 motors are kind of fairly well decoupled from the belt, which is actually finally driving the platter there. Here is an attempt to isolate the arm mounts. They're not kind of connected to the sub-chassis of the deck. And then you've got the suspended sub-chassis. We're looking at elastic band. This whole thing's floating. You can float up and down. It's held by elastic bands here. That's again an effort to isolate the actual functioning part of the deck from ground-borne vibration. By the way, a lot of vibration that gets, when I say ground-borne vibration, a lot of the vibration is actually happening because the record player is sending vibration into the surface it's sitting on, which then wants to get reflected back in. A lot of people don't just think it's feedback from the speakers, but you can turn your speakers off entirely and you'll still notice huge differences between just putting the record on here, say, and putting it on the floor, just purely because it's kicking out so much vibration. And again, you've got to think 8,000 times, because otherwise everything sounds so far-fetched, it's just crazy. You know, you think, seriously, these men in the white coats should come and take you away. This is, again, another attempt to minimise resonance. And a lot of, if you have a plinth, which is the bit that everything sits on, you notice these huge plinths, that will resonate. It's like a board, it's like sound, it just resonates. So to get rid of that, just get rid of the plinth, use a skeletal design. These are some of the tricks that people use in turntable design. And it's a tough environment, actually. I mean, we've been very fortunate in picking up, I think, about 17 awards over the years from various magazines, Product of the Year, for what we do. And it's very hard to come up with a really, really good design that will outperform a lot of the competition. This is a quite clever design. This is a huge pendulum. The whole thing is actually mounted, and it'll swing backwards and forwards. And this is a pendulum at the bottom, and it's designed on the principle that the highest tower in Taiwan uses to try and avoid crumbling under earthquakes. And they've got this massive weight at the top, which will swing and counteract the effect of earthquakes. So again, £100,000 design. Air Force One, we've got vacuum clamping. It's another thing people use to try and stop the platter, the record itself resonating. What they do is they suck it down with air suction onto the platter. Very expensive piece of kit, about 70,000. How are we doing for time? Okay, 5 minutes to get through bearing design. When it comes to tone arms, there is an astonishing amount of creativity about how people want to do the bearings, and I just thought it'd be good to run through a few of them. I'm not going to, by the way, on these designs, I don't want to comment on which is the best and which is the worst, because so much of audio design is about a balancing act between two completely conflicting principles. For instance, on tone arms, you've got the principle of it should be really stiff so that when the cartridge wants to kick, it's got a stable platform to kick against, so it's got to be rigid. But the problem with a rigid arm is when it goes into resonance, it tends to go into resonance for a very long time. So you get thin arms to try and reduce your weight and get low resonance, and you've got thick arms to try and make them stiff. So which way do you go? Do you know what I mean? It's just really, this is why there is so much diversity. Bearings are a fantastic example of very creative thinking. The most common is just the two ball bearing races, where you've got a bearing. This round circle is the tube, the arm tube, if you can imagine it coming straight out. So you've got two bearings either side of the arm tube. The uni-pivot, which is very finicky, a lot of people hate the setup, but you've just got a single point into a cup, and that's got a very low centre of gravity, so the whole thing just balances on a point. We use actually a kind of derivative of the uni-pivot, which is dual pivot, and this is about 4 other people in the world use this. I think it's the best compromise because it acts like a normal gimbal arm, but it's got very low friction, the sound is very fluid and free and open, which is what people love about our arms. You've got this one, which I was going to say it's terrible design. We tried this, and it is no good. It's just horrible.
We got there at the end, a billion, hurrah.
Yeah. And then you've got the knife edge. SME used this many years ago, which is very similar to this, except it's not quite the same. The arm here is moving backwards and forwards on 2 knife edges on either side of the arm. You've got magnetic arms, which are suspended in space, completely free. You'd think that was had to be the way to go, but things have to be earthed. You have to get the vibration out of the arm, and that's why we don't particularly like that design. You also got the arm which hangs on a single thread. Some people put a magnet underneath it to give it a bit more tug, so it's a bit more stable and doesn't kind of fly all over the place. And then a recent arrival on the scene about 4 years ago was a ferrofluid bath. So here you've got the arm, and it sits on a little float which wanders around in ferrofluid. We've got time for some questions, I think. So, yeah.
Is there any way of doing it without contacting the vinyl, like a laser?
Laser has been tried. There was a laser-guided deck that came out many years ago. The problem it has is reading the depth of the grooves. It can spot the side-to-side grooves, all right, but it has great difficulty figuring out the depth, and it never went anywhere. I don't think there is the answer.
There is now one that actually picks up the diamond movement using optical technology from ice, and it's still contact as well.
Yeah, thank you. I was aware of that one as well, but it was contacting, so yeah.
Can I ask an ignorant question? I went online, looked up turntables, and one thing that I never thought about was the fact that the hole for the record is never exactly in the middle. And what we've all seen is the tone arm going side to side as the record goes round, which inevitably gives you wow as the record goes round. You can have the most massive platter in the world which goes round absolutely steadily, but if the record isn't right, you get wow. I've no idea whether this is audible.
It is just audible, yeah. But you have to be.
I guess you know that Nagamichi a long time ago made a self-centering thing that actually moved the record so that it was central. Please comment.
Yeah. There are people who can spot this and hear it, but I have great difficulty myself. I think if you kind of know a record is off centre, you can probably tune your brain in to pick it up, but I don't normally notice it. It's a very, very small effect. There's one other thing I was going to say on this.
It's on long notes.
Long piano notes.
Yes, I'd suggest that sometimes the devices to self-center records say that the cure can be worse than the disease, and that you've got anything that kind of interferes with the patterns of vibration can cause upset. So it would be a very complicated design to get to sound any good as well.
What's your view about adding mass, like in the form of a weight on the record, or adding mass to the blend?
It's a great idea, and it's very hard to get right. We are actually trying to develop something ourselves at the moment. The problem is that on 70% of tracks it sounds great, but on the remaining 30% you actually lose a bit of the high frequency. But the good ones, and the only one I've ever heard which is really good, cost £2,000, Shunmuk. So I passed on that one. So, sorry, yeah?
I was going to say, some of your turntables that you showed that they have two tone arms or multiple tone arms, and I also know there's some which are parallel reading. I just wonder whether you have the opinion on different sort of design of how a multiple tone arm one works.
People use multiple tone arms. I mean, one of our clients in Switzerland uses 3 because he likes to use different cartridges. For instance, if you've got mono records, you'll want to use a mono cartridge, and you really don't want to kind of spend half an hour mounting your cartridge every time you want to play a mono record. So people do it for that reason. Sometimes they might have second-hand records they bought from the junk shop and they don't want to use their £8,000 cartridge on those kind of records, so they have another arm. There's people like to play around a bit. Parallel trackers, I have serious reservations about parallel trackers because I think there's a lot of side loading that goes on the cartridge, which could not be, well, it's bad use for records basically. Yeah, sorry, there was a guy, you were...
I just wondered if you knew what equipment the BBC use.
They're almost certainly
using a certain standard, haven't they?
Yeah, they're almost certainly using a direct drive turntables. Most broadcasters are using them, mainly because they're so quick to start and stop.
You're consistently talking about faithful reproduction of what's on the record track. Now you are not exceeding the faithful reproduction of the record track in terms of the original music. I mean, I'm basically talking about, are you exceeding, are you going beyond the quality of manufacture of the vinyl in the first place?
I think we can only, we are at a serious disadvantage in some respects, because sometimes if the record producer doesn't do a great job, there's absolutely nothing you can do. Seriously, you've got a bad record and no equipment in the world will ever rectify that. It's the old thing about rubbish in, rubbish out.
Yeah, but by producer, you're talking about the actual stamping of the record, or however it's created.
It could be in the record.
The manufacturer I'm talking about is how, you say how fine all of this is, and I'm then thinking how difficult and demanding. I mean, you've got all these people working on turntables. Is that same effort being put in to get that same quality in the manufacture of the
Oh,
track in the
okay,
first
yeah,
place.
no, I understand, yeah. Well, the answer is that in some quarters it is very, very, I mean, we're going to be playing a track which is called Direct Cut here, and there are some people in the vinyl production who are putting enormous efforts into getting a really good cut of record, and I mean, it's fantastic. The difference is, you know, is as good as you can expect, really. Sorry.
Yeah, should we go with one more question?
One more question.
And then,
Yeah.
is it? Yes.
About 30 years ago, they were doing direct cut quadraphonic records, and you could hear with the speakers where the different instruments were. What is your feeling about it today and where it's going?
I'll definitely let my chauffeur answer that question. No, that is a really hard one. To be honest, I have to pass on it. Quadraphonic was just when I was getting into records. I don't know enough about it.
Another hand went up at the same time, so in the
Just-
defence.
It would have been interesting to see a picture of your products. I'm sure most of us in here would have liked to see what the product actually looked like.
This is one of our Tonearms. Again, oh, it is working. Fantastic. The animation. Yeah, this is the latest arm we've got under development at the moment. It's a really high-end arm. I mean, arms at the moment, our main competitor is probably 30,000, and our top arm is only 5,000. But that £5,000 arm still has, I don't know of any equal to it at all.
And
So-
presumably we've got examples of the product as well.
Yes, you do, yeah. And we've got brochures at the back as well.
Mark, thank you very, very much indeed, and we'll have maybe a few more questions at the end, and then of course the opportunity to demonstrate. But in the meantime, thanks very much, really fascinating.